Who's me?
Isai.
Okay, perfect. Thank you. Yes, they did ask for the difference. So they really asked for 4 minus 3.3, which should give you 0.7 hours. So your final answer for part A should be 0.7 hours. And here we have 3.37 minus 2.89. And let me do that real quick. 3.37 minus 2.89 should give you 0.48 hours. Okay, so your final answer for each of those should be that difference. So thank you very much. I really appreciate that, Isai. Okay, any other questions? All right, great work. So we're going to go ahead and start with number 2. So number 2, it gives us a chart that we need to fill in first. Let me scroll down. Okay, so we have average speed, and we have time in hours, and then this one is in miles per hour. Okay, and we need to fill out a chart of values. Oh, my little square is getting in the way right here. Okay. Okay, so we go up by 25 miles per hour each time. So we have 50, we have 75, 100, 125, 150, 175, and 200. So we need to fill in all those values. I'm going to call on each of you to see what your solution is for each one of those values. We do already have 2 of them. We solved for them in part A. 125 is 4 hours, and we have that 150 is 3.3 repeating hours. Okay. All right, so let's see here. Jakaya?
Yes.
You can, would you like to pick one or do 50? You can pick a different one if you want to.
50.
All right, 50. How long does it take?
10.
Yeah,
hours.
beautiful. 10 hours. All right, and we're doing the exact same thing we did up here to solve for each of these in case you're confused. I'm just going to go through real quick and tell you the answers, or have you guys tell us the answers. Isai, can you do 75 for me?
6.6.
Beautiful. 6.6 hours. Betsy, actually, I don't think Betsy was here. Betsy, are you here now? Okay, Roxy, can you do 100 for me?
5.
Beautiful. Thank you very much. Peyton, can you do 175 for me? Peyton, are you here? Maybe Peyton was in here. I'll set you to the side. Eddie, I don't think was Eddie. Wait, no, Eddie's here today.
I got 2.86.
Thank you. Perfect. And Nakaya, can you do 200 for me?
Is it 1 point something?
It's not 1 point something. So what we're doing is we're taking 500, which is our distance, and dividing by 200. So 5 over 2 is, what's half of 5?
You said divide like 500 into 200?
Yeah, the opposite, dividing 200 into 500.
2.
But those zeros get canceled, so 5 over 2 is...
I said the answer 2.5, right?
Oh, yes, I didn't hear you. That's correct. Perfect, 2.5. Okay, so these are the solutions for your chart. Hopefully you got the same answers I did. If you did not, please ask a question real quick. All right, I'm going to assume that means no questions. So in part A, it tells us to fill in that graph with the data points that we just created in that chart. So I'm going to go ahead and fill that in for you guys. So let's see, we need, let's say this is 10, 8, 6, 4, 2, have 0. Okay, and then we need 50, 100, 150. Ooh, did this yesterday, my pen kept going out. 150, 200, and 250. Sorry, my tick marks are not very even at the bottom. And my pen keeps dying. 250. Oh, this is ridiculous. That last one is 250. I'm very sorry. Okay, so we have our graph and we have our point values up here. This bottom piece was the average speed. Okay, and this is time. Is somebody trying to join? Hold on. Yeah. Hey, Juan, welcome. Okay, so we have our average speed on the x-axis, our time on the y-axis, and we're going to use these points to plot. So my first data point is 50, 10, so I need to go along to 50 and then up to 10. Then my next one should be 75, 6.6. So 75 is going to be halfway between here. And then I want like almost 7. So maybe about right here. Then I want 105. 125, 4. 150, 3.3. That one should have been up a little bit more to get it perfect. And then let's see, we were at 150, 3.3. 175 is 2.86. So a little bit over 3, or a little bit under 3, I'm sorry. And then 200 should be at 2.5. So maybe right about here. So our curve should look something like this when it goes through. Okay, something like that. And then it says describe the relationship between the two variables. So they decrease together. Okay, both of them are decreasing, but the average speed, decreases faster than the time. Okay, so they're both decreasing values. We're going down. Actually, they don't decrease together. So speed decreases, but time is, I'm sorry, time is decreasing. I'm being an idiot right now. So time is decreasing, speed was increasing. Okay. And so average speed is increasing faster than the time is decreasing. I'm sorry if that was confusing. What did you guys say? Because I just totally botched that. Nothing? So I said time is decreasing, speed is increasing, and the average speed is increasing faster than the time is decreasing. Okay, so we have equal intervals on our x-axis here. These points are equally spaced in this direction, but here, like this y value jump is a lot bigger than that value jump. Okay, so that's what I was trying to get at. Part B says write a function rule that shows how to calculate the race time as a function of average speed in this particular race. We have kind of done this together already. We used this in part B and in filling out the chart. So we're looking for a function of speed, or I'm sorry, we're looking for a function of time. and we want it in terms of speed. That means that speed needs to be over here somewhere, and it's specifically for this race, so we want to use the distance for this race. Ayana, can you tell me what this equation is going to be?
Yes. In front of the equal sign, I put an R, then I put S in parentheses.
You
And I
put R and like this?
Yeah. Yeah, then I put equal 500 over S, or 500 over 5.
Why'd you do that? Where did R come from?
Because I didn't know how to write it, so I just wrote something.
So why did you write this though?
Because on the chart, it was race time, then it was average speed, and we divided it by That's where I got that from.
R represents, also, did you just copy this?
What?
This right here? Because the answer
No, I got help from my friends.
says.
At first, I did T equal 500 over 5, but then I went to the chart.
That's fine. No, T equals 500 over 5 is what I was looking for.
That's what I had at first.
Not 500 over S.
Oh, no, I had 500 over 5 at first.
Oh. Why'd you have the 5?
Because, I don't know, I keep getting 505 confused. Because from the chart, when we was dividing the 500 by the average speed.
Yeah.
Yeah, I don't know where I got 5 from, though, but that's what I had at first.
Maybe you accidentally thought your 5 was or your S was a 5, because S would make sense because that's speed, right?
Yeah.
So the way that they have it written in the answer key, they have R of S. This is function notation. So this is saying our function is named R for race time. Our input is S, okay? So that's all it's saying. If you wrote T equals 500 over S, that's perfectly fine as well. Okay. All right, so that is A and B of number 2. Sorry, it got a little messy and that I squished this B all the way in there. Okay, so let's go back up to number 3. I'm very interested to hear what you guys have to say for number 3. I'm gonna flip my paper. I will post a copy of this paper and also this video if you guys got really confused. So don't worry. Or if like you didn't have time to write everything as we were going. So 3 says, it says in the 1960 to 61 race and the 1970 to 70, I'm sorry, 1997 to 98 races, the comparisons of the winning speed and time for the Daytona 500 race, I don't know, that first part of the sentence is weird. The differences in the average speed are both 25 miles per hour, but the time differences are not the same. So if we look back, it's referring to number 1. Okay, so we had the race speeds for 60 and 61 here. Notice the speeds 125 and 150. The difference there is 25 miles per hour, right? 125 plus 25 is 150. Same here. So 148 to 173, there is 25 miles per hour in between those values. But notice that our difference of race times up here was 0.7 and down here was 0.4. That is a significant difference in time. Okay, this one's like almost a whole hour and this one's like a half an hour, right? So it's pointing that out, okay? It's also pointing out, I guess I can show it here, what we were talking about with this graph. Here we have we go up by 25 miles per hour every time in this table, and we are going down by smaller increments each time. These time differences are smaller. So in part A of number 3, it says, how is the fact that equal changes in average speed don't imply equal changes in race time illustrated in the shape of the graph and the data? Okay, so for part A of number 3, 1, I know you just joined, but can you try to answer? Give me what you wrote down for number 3A for the homework for last week. Juan, are you there?